Good evening, everyone. First of all, thank you for Emertx that provided this internship to us. Our teammates are Satyavani and Satyarukmini, myself Sai Hemant, and this presentation is about IoT-based home automation. We are from RGU Triple to Ongol, Andhra Pradesh. Our project guide is Jayalakshmi and Danyala. Thank you, ma'am, for providing this, teaching us in a well. Okay. The outline of the project is Languages Learned, Internet of Things, Embedded Systems project. In this overview, objective, design elements, simulation, and conclusion are all about this PPT. Okay. Let's go about internship. This internship is provided by Emertx to create a project on home automation using IoT. First of all, we discuss about what the topics are covered in this internship. C programming. In the first week of the internship, we are discussed about C programming. In that we discussed deeply about C programming coding, loops, loop statements, condition statements, etc. And then we studied about basics of C++, embedded C programming and embedded systems. We discussed about introduction to IoT, Internet of Things, and then we learned about Arduino, UNO, LED, CLCD, etc. Okay. Simulation tools used for the project. Arduino IDE. IDE is used for Arduino programming and to generate the hex files. PixSimLab. This PixSimLab is used for simulation and running the hex files created using Arduino IDE. And then coming to null emulator, this is used for serial communication between Arduino IDE, PixSimLab, and the serial tank, which is used for the simulation of the project. And then we used LVSD and Blink Cloud and Blink IoT mobile application. By using this mobile application, we control the temperature and other parameters that are required in the project. Okay, let's go take a look about IoT, Internet of Things. This describes the network of physical object things that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Okay, IoT is a network of physical devices, home appliances, and vehicles that are connected and exchange data over the internet. This IoT is used in various fields, like in automobile, wearable health monitors. In business sector, it go for home automation, which is our project right now. In agriculture field, it's about smart irrigation. In transportation, it is used in traffic management. This is a block diagram about the IoT. It can be used in various sectors like edge IoT devices, data centers, IoT enabled homes and buildings, IoT enabled cities, IoT enabled ships and airplanes, trains. From mobile, we can operate anything. Okay, let's come to embedded systems. Embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specified task. It mainly has three components: its hardware, its software application, and it has a real-time operating system RTOS. Okay, let's come into the project introduction. Home automation is a technological solution that enables automating the bulk of electronic and technology-based tasks within a house. In this project, we are automating five things in the smart home, like garden lights control, temperature control system, cooler control system, heater control system, threshold temperature control. Scope. Let's discuss about the scope of this project, how it is useful in various fields. The home automation should be simulated on the Pixim simulator. Blink IoT mobile applications used to control the device. By using Blink application that is provided in the mobile, we can control the home, so many of the devices in the home, which we can call as a smart home. The assumptions in this project are all the peripherals are simulated and no real-time objects are interfaced. Here no real-time objects are being used, all are simulated in the project only. Dependencies, it is dependent on the Blink mobile app. There are no constraints in this project. This is take a keen look at the mapping of the project. By using mobile app, Blink application, we simulate in the Pixim lab and then it will used in the house applications. Okay, let's discuss about the Arduino IDE. It is an open source electronics platform based on I2Use hardware and software. It consists of microcontroller board and a development environment which is used to write, upload and execute the code on the microcontroller. Next, we will discuss users to simulate the behavior of a microchip, microcontrollers, and various peripheral devices. It is an open software, so everyone can make use of it. Like for Windows, Linux, OS operating systems, everyone can easily use this. Okay, take it. And then LDR sensor. This is the photo of the LDR sensor module. LDR means light dependent resistor. It is an electronic component that exchanges its resistant value in responses to changes in ambient light levels. And then it is also called as a photoresistor or photocell. Okay, wait, I'll go for. Okay, now we will discuss about project requirements. First one is the garden lights control. We have to read the LDR sensor value. Based on the reading from LDR. The brightness of the LED will be changed and the LED will be blinking according to the brightness of the light. It resembles the controlling garden lightnings based on the availability of the sunlight. Take a look at the block diagram of this Arduino to LDR sensor. Temperature control system consists of a heating resistor, an LM35 resistor, temperature sensor, and a cooler, which resembles the temperature control system at home. The temperature from the home temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on or off heater. Okay, take a look at this and then come to water tank inlet and outlet valve control. It is used to control know whether the tank is filled or not. Read the volume of the water in the tank through serial communication and display it on the CLCD. And then the inlet valve and outlet valve are controlled by the volume by sending commands through serial communication. The display of the volume in the water tank is displayed on the CLCD. This is all controlled by Blink IoT app. It will pass through Arduino UNO and CLCD to the water tank. Okay, user interfaces. This is a interface of the Blink application. Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. Button widgets to control heater, cooler, inlet valve, and outlet valve. Guard widgets to display temperature and volume of the water tank in the mobile applications. Here we can see a home automation in tab 2. It will the temperature is shown here. If the temperature is low, if the temperature is high, the cooler will be on. If the temperature is low, the cooler will be off. And here we can see inlet control and outlet control, which is used for water tank, the serial communication. Terminal widgets to display the notifications whenever threshold is crossed, like temperature is more than 35 degrees. Okay, what is threshold control? When the heater is on, if the temperature rises above 35 degrees Celsius, then heater should turn off automatically and message temperature is more than 35 degrees Celsius. Turning off the heater should be displayed on the virtual terminal on CLCD. Here you can see in the event window, water inflow enabled, water level is full, water inflow disabled, temperature is more than, and then so on, water inflow disabled. Okay. Now the simulation will be taken by Satya, our teammate Satya and Satyaveni. They will explain about the simulation.
Code for this home automation project. First of all, we are including all the required header files and libraries into it. Then we are writing our authentication code, which is of Blink Cloud. Then we are initializing the variables, declaring it, and we are including the libraries that is required. Then we will mention different functions and their definitions into it. So this cooler weapon function defines, it gives us the control to control the cooler by clicking it on and off using our mobile apps, and the LCD will display the cooler is on and cooler is off. Similarly, when it comes to heater weapon, this will take the input and then it will also display when the heater is on, it will show on, and when heater is off, it will show off on the LCD screen. The inlet V pin will display the inlet flow of water tank. So it will again enable the inlet, and it will show that the cursor on the LCD screen whether the flow is on or off, and it will take parameters. It will read the values from the Blink app. Similarly, for output pin, it will again show whether the flow is on or off on the LCD screen, and these methods are called enable outlet and disable outlet. Update the temperature reading will be helpful for us to give the values to IoT app. So basically the app will show the display of the temperature as the temperature is moving. Even the water value will be displayed on the mobile app. When it comes to handle temperature, this will check if the temperature is greater than 35 degrees, then the heater will turn off, and then it will print as the heater is turned off. And similarly, a notification window will appear on the mobile IoT app where it displays that the heater will be off because the temperature is exceeding 35 degrees Celsius. When it comes to the function of handle tank, this will mention that if the tank volume is less than 2000 and the inlet valve is closed, at that moment it will turn on the inlet valve and it will show that the flow is on, and the notification will be printed on the mobile app that water level is less than 2000, so the flow will be on. Similarly, if there is the volume of 3000 and if the inlet valve is open, at that moment it will disable the valve. That means the flow will be stopped and it will be mentioned on the LCD that the flow is stopped. Simultaneously on the notification window of the app it will be mentioned that water level is full, so flow is stopped. In the setup we will always initialize, will always declare the init methods, and in the loop we'll always call the method that is already declared. In ldr.cpp, in this file we are declaring the brightness control method, which means this method will declare that the blinking of LED with the help of LDR. In ldr.h, it is the header file where we have declared the macros, LDR sensor, and we have given it as a value, and we have also defined the methods. In main.h, here also we have declared all the macros that we are using in the program. Serial tank.cpp will be declaring all the methods into it. In this volume method, it will declare the volume, how much volume is there in the tank and not. And the different methods like enable inlet will show that the inlet valve is enable or not, disable inlet, and various methods are declared over here. In serialtank.h, that it is the header file that will mention all the macros in it, and the method names are declared over here. Temperature system.ccp will give us about the method's name, that cooler control. That means it will give digital write cooler dot control, which means that the values will be read by the system when the machine is on and off, and it will be passed and declared in the LCD. Similarly, when it comes to temperature, this will convert the temperature into degree Celsius. This method will be helpful for converting the temperature into degree Celsius, and it will declare all the method that is required for the temperature system. And the temperature.system.h, this is the header file where we are already declaring the method names and we are declaring all the macros. In this way we'll be able to code our system, and once our code is ready we'll compile it and we will upload the compiled code in the Arduino of PiximLab. Once the compilation is done, the hex file is ready. Here the compilation is done and our code does not have any error, so we can upload it on the PiximLab. Now let's look at the simulation part. So this home automation project consists of blinking of LED with the help of LDR. When we lower down the resistance, the light turns off, and when we increase the resistance, the light will turn on. Remaining part can be controlled by our mobile application. Here I have kept on the Blink app where we can see the option of cooler. When we click on, the cooler starts to on, and over on the screen we'll see the cooler is on. When we click on the option off, the cooler will stop and it shows as the cooler turns off. When we click on the heater on, the temperature on the screen will increase, and when it turns above 35 degree, automatically the heater turns off. And here we get a pop-up message that temperature is above 35 degrees Celsius, turning off the heater. If we again turn it on, it will increase the temperature, but automatically again it will turn it off. And when we turn on the cooler, the temperature decreases, the fan also turns on, and here on the screen we'll also get the temperature is decreasing. Similarly, if we turn it off, it turns off. When we go to the second tab, which indicates the water level, we can see it with the help of the serial monitor, where we'll see this tank over here. So let's look at the tank. So this is the tank. If we keep the inlet on, the tank is filled. Once the tank gets filled, automatically the flow is stopped. When we turn on the outlet valve, the tank is decreasing. Here on the screen it shows outlet is on, and once it decreases below 2000, the inlet will get on. See, here the inlet is on. Again, when we stop the outlet, on the screen outlet is off, the inlet is full, and once it completes 3000 liters, automatically inlet will be off. Now the inlet is automatically off. We can turn on the outlet to check the water is decreasing. Here on the screen also it is decreasing. And on the tab 1, we can see a notification. The notification shows that the water level is less than 2000. So water inflow is enabled. And if the water level is full, the water inflow is disabled. In this way, we are able to control the water level over here. So basically in this internship, we have completed a project that is based on IoT home automation, for which we have just now seen the simulation. So basically what this project does is, this project we are controlling from a Blink IoT app from our mobile phones, where we look that when we turn on the heater will start. It will show on the LCD screen. So heater turn off mechanism is controlled by this app. Then cooler